All right, guys, we are back and we are working on 79 from 2.2. Again, it's a difficult problem similar to the one we did. I'll do it in detail once again. So I want to know where this point is. This point has its coordinate, its x coordinate is positive, its y coordinate is negative. And that simply means it's somewhere here. Here, I'm going to draw a line. And let's see if this is 2 comma negative 3. All right, fine. Now I will put a little point here, make it green. Okay, this green point, I'm going to make it a little bigger. Again, where you put it exactly, is it accurate? Nobody cares. It doesn't matter. All right, so this is 2.2 and negative 3. Now I am going to draw a little right triangle here. Okay, and I am gonna find this height is gonna be negative 3. It's the y coordinate, negative 3. And this base is gonna be 2 because that's the x coordinate. And I'm gonna use Pythagorean theorem to find this length. And I can guarantee you it's not gonna be 1 because I did this problem earlier. So how do I call this r? I call this r as in radius, and Pythagorean theorem allows me to draw this conclusion. And 2 squared is 4, negative 3 squared is 9, 9 plus 4 is 13. So R is square root of 13, which is what? Which is clearly more than 1, right? Square root of 1 is 1. Square root of 13 is more than 1. I'll show you what it is. I will write it as square root of 13, okay? In trig, we try to be as accurate as possible. So square root of 13 is about 3.6. I'm not going to worry about it, okay? We are being recorded. Let me double check. It's here. You know that square root of 13 is 3.6. So it's clearly more than 1. And uh, it is 13. So let me draw a unit circle. Again, the size doesn't matter. It should be roughly smaller. All right. Now we do something like we did before. I'm going to make this point pink. And the pink point, let's say the pink point falls on the unit circle. So R, I am going to write square root of 13 now. Don't need this. I'm going to write R as square root of 13. Why? Because I know it is. All right. This big length is 3.6 or square root of 13. Okay. The small length is 1. So I'm going to take this big line divided by square root of 13. I'll get this line here, tiny line here. If this is negative 3, I'll take negative 3 and divide it by square root of 13. I'll get the value of this here. And I'm going to write it carefully as follows. This is going to be 2 over square root of 13. 2 over square root of 13. The base of that little triangle. By little, I mean the one on the unit circle. And what about this guy? That's going to be negative 3 over 13, square root of 13. Now, I have my coordinates of the pink point. X coordinate is this guy, and the Y coordinate is this guy. Let's write it down. Let's write it down. What difference does it make? On the exam, when you're taking the exam, you don't have to write it down, but I will because I'm trying to explain things. All right, now I have my coordinates, and that's good news. I have done all the hard part. I've done the hard part. Now I have to do the easy part. Let's pause it a little bit. Let's see if people have any questions. How did you do that? How did you get that? Okay, guys, I'm going to take this picture to the next slide and see what I can do. Give me 1 second. Sorry, I do want to include this. Don't need this. Let's move on to the next. Now, it's the same problem. Working on the same problem, but I do know they they want me to find sine, cosine, and all the other things. Okay, as we have done before, sine is sine theta is simply the y coordinate on the unit circle. So that's going to be -3 over square root of 13. All right. Cosine theta is simply cosine theta is simply the x coordinate on the unit circle at that point. Okay. And we're going to find the reciprocals, but this one is sine over cosine. To find tan theta, I can simply cancel this because I'll be dividing this by this. I can cancel those. And that's exactly what I'm going to do. And I'm going to just find tan theta right now. All right, I have the three main ones, and the other three are reciprocals. So let's start with tan. The reciprocal of tan is cot, and the reciprocal of cosine is secant. That's going to be, and the reciprocal of sine is cosecant. Done. I got all six ratios. Let's pause here a little bit. I have both slides. If you have any questions, guys, I can go back and explain this, and I can explain the last part. I don't think that most people will have trouble with the last part. I know that. But these are your answers. Sine, cosine, tangent, cotangent, secant, and cosecant. You have it all. You just can't assume this point is on the unit circle when it is not, and nothing we have done will hold if the point is not on the unit circle. So we employ a trick. What's the trick? We find out how long this radius is. If it's more than one, we divide everything. And we're going to do one example where it'll be original point will be inside the unit circle, and you're going to go out, which is exactly the same, really. It's not hard, so don't worry too much about it. Let's pause there a little bit for people to process, okay? Just a couple of minutes. All right, guys, let's do one more. And you're going to see, I'm going to do 83. And 84 is exactly the same. You're going to see this point, 1/3 and 1/4 will be inside the unit circle, not on the unit circle, but will be inside. Now, um, I'll just pick it up from here, but it's 1/3 and 1/4, 83. I'll remember it. How's that? 83 is 1/3 and 1/4. Same problem. All right, so what is 83? 83 is this problem. You'll see it. All right. So this is a point, and everything we said so far, it's a line and point of a line. You have to find out which quadrant it's on. It's in quadrant one. Both are positive. Okay. And I'm gonna say, let's say I need a bigger picture. Okay. This point will be somewhere here. Again, nobody cares exactly where it is. I'm gonna just write one. I'm gonna say, okay, this is 1/3 is bigger than 1/4. So I'm gonna say it's somewhere. Doesn't matter. Okay. This point is somewhere here. All right here. And let's make a big green circle. That's gonna be my point. And the coordinates of this green point are 1/3, comma 1/4. Now, these are the coordinates of the green point, guys. All right. Now, using the exact same technique, I know that people don't like fractions, but they're not that bad. I'm going to find out the length of R. Same technique, Pythagorean theorem. This length is 1/4. This length is 1/3. Remember the Pythagorean theorem, you square everything. R squared is equal to 1/4 squared plus 1/3 squared. Okay, 1/4 squared is 1 squared is 1 divided by 4 squared is 16. 1/3 squared is 1 squared is 1 divided by 3 squared is 9. Yeah, we have to do a little bit of work. So guys, how do we add to, you can use your decimal. Trust me, it's not going to work. You have to do it the old-fashioned way. Now, the common denominator and all that, I will do it here, but most of you know how to do it, I'm sure. I'm going to write 1/16 plus 1/9. I'm going to take this denominator 9 and multiply this fraction 9 and 16 both by 9. And I'll get 9 divided by 9 times 16 is 144. Okay. I'm trying to make the denominators identical. I'm going to take my 16 and multiply both top and bottom by 16. The top will be 16. That's easy. And 9 times 16 is 144. We just checked it. And now that the denominators are the same, you can add or subtract the numerators. 9 plus 16 is 25. I'm just going to add because that's what the sign says. And that's my R square. My R square is 25 over 144. Okay, when you add these two up, and I'm going to write it down here. I'm going to write it down here. Now here I did it, um, but you have to do it and you have to keep it straight. Okay? It's not that difficult to add two fractions, but you have to be careful. You don't want to mess it up. Now I do really want R. Okay? So I'm going to get rid of this if you don't mind, just a distraction. R is going to be the square root of both left side and right hand side will get me to R, and R is equal to square root of 25 is 5, and square root of 144 is 12. It's 5/12. And remember, guys, I told you this time it's going to be less than 1. Clearly, 5/12 is less than 1. It's even less than 0.5. So my unit circle is something bigger around it. So, oh boy. So let's pause here a little bit. I can do one thing. I'm going to do it like this. So if you would bear with me, I'm going to actually shrink it a little bit because I need the room. Okay? I'm going to pretend my green line is a little smaller. All right. Now, my unit circle is going to be somewhere around it. Has to be because it's bigger than the unit circle here. I'll try to be as nice as possible. It really doesn't matter as long as it's relatively accurate. That's good enough for me. Okay. Now this line is going to extend out, right? This point is I'm going to write 5/12 here, which is smaller than 1. And this green point is this. And my pink point is the one on unit circle, okay? That's what I'm really interested in. Excuse me, guys. I know it's a tiny problem, but a lot of work, and calculators don't come in very handy if you don't understand things. All right, guys, so I want to know how to go from this to 1. How to go from this 5/12 to 1. Now, basically, you will be multiplying by the reciprocal. Take a look at this, guys. From 5/12, if you want to extend it to 1, if you multiply, I'm going to show you here. I'm going to show you here, but I think you'll understand it. 5 divided by 12 times 12 divided by 5 will give you 1. Isn't it, guys? So if you have to multiply everything by 12 divided by 5. Where's 12 divided by 5 coming from? 12 divided by 5 because this thing is 5/12. So you multiply 1/3 by 12/5, 1/4 by 12/5 to find the coordinates of this point. And that's exactly what we're going to do in a second. So I'm going to do it here, but I'm going to eventually write it here. So 1/3 times 12/5 is 3 goes into 12 and you get 4/5. Okay, so 1/3. If you multiply this by 12/5, you're going to get the big one. To get this big one, big line, you multiply 1/3 this length by same 12/5, you get 4/5. This is 4/5. Using the same method, and if you multiply this 1/4 by 12/5, I'm going to do it here if you don't mind, because I need room, you get 3/5. 3/5, and you get 3/5 here. You have your coordinates and you're good to go. I'm going to get rid of this. Now, I'm going to check in my head, if you actually square 4/5 and square 3/5, trust me, your hypotenuse will turn out to be 1. I can see it. 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, 25 divided by 25 is 1. So I know I didn't mess up. Okay, so let's see. I want this picture to be on the other page. Let's see how I can do it. If you don't mind, I'm going to get rid of this. Let's bring this guy to the next page and do some math. Don't worry about the value of R. We don't need it anymore. Now I know the pink dot is on the unit circle. I know it. And I'm going to just do some math. Clearly, sine theta is going to be, if anybody wants to chime in, be my guest, it's going to be 3/5, which is the y coordinate, and cosine theta is the x coordinate, and that's going to be 4/5. Okay, cool. Now, tan theta is going to be, if you divide sine by cosine, you're going to cancel the 5's, and you're going to get tan theta will turn out to be 3/4. Then you can find the reciprocals. Those are the easy ones. Cosecant, 5/3, and cosine, reciprocal of cosine is going to be 5. Secant is going to be 5/4. And the reciprocal of tangent is cotangent. And that's going to be 4/5. Done. We have all 6. Let's pause here a little bit. Okay. So we did 3 problems from this out. Well, I'll pause. I'll pause for a little bit. So we kind of did wrap up 2.2. You should be able to do all the problems, and I'll be happy to take questions. Do this, do that. No problem, guys. Other than that, I don't have a whole lot to share right now. Um, if you have questions, hang around. If you don't have questions, go home and study. Um, I will switch, come back. It's 10:25, 26 there. I'll come back really fast. I'll be happy to take your questions. And if you ask me something that's worth recording, I will record. If it's informal, can you explain that again? I probably won't. So I'll jump out of this session unless you say, hey, I have a question on this slide. I'll hang around. I'll jump out of the session. I'll come back really fast. Good luck. Don't miss the exam, guys. It's an open book exam, open book. Use your calculator. Try to take it on time. Try to 2 hours should be more than enough. None of my students complain about time, so don't ask for extra time. I would appreciate that if you didn't. Thank you very much, guys, and good luck. I'll see you soon if you have any questions. Bye-bye.